Assalamualaikum warahmatullahi wabarakatuh dan salam sejahtera. Pada hari ini saya akan teruskan lagi Chapter 10 Special Probability for 10.2 is Poisson distribution. Okay, for this subtopic, after this lecture, you should be able to identify the Poisson distribution. Next, find the mean and variance of Poisson distribution. And the third one, use the Poisson distribution to solve related problems. Okay, first identify the Poisson distribution. Poisson distribution is used to model situation where the random variable x is number of occurrence in a given time interval. So time interval such as time, volume or space. The Poisson distribution is a discrete random variable. Serupa dengan binomial, Poisson adalah satu discrete random variable. Okay, now we look for four conditions of Poisson distribution. Okay, first, the number of occurrences is a discrete random variable, as I said yearly. Right? Please remember the number of occurrences is a discrete random variable. Okay, next, the Poisson distribution is the probability that an event occurs in the same for each interval. Next, the occurrences are independent. For each event, the occurrences are independent. Next, the lambda is mean, refer to mean or average or expected number of x. Okay, this is a few examples for time interval. Okay, first, the number of incoming calls into a telephone in a day. Right? So, day is time interval. Okay, maybe we have a day, week, month or year. Maybe 2 days, 2 weeks or 2 months or 2 years. So day is time interval. Okay, second, the number of misprints in a book. Okay, this one contoh yang kedua tentang Poisson distribution. The number of misprints in a book. Okay, this is about space. Okay, in a book, about space. Another example, maybe sheet, book or page. Next is radioactivity count per second. Right, dia bagi in second. Second is time. Maybe we have minute, per hour, per second. Okay, this is contoh bagi time interval time. Next, count of bacteria colonies per Petri plate in a microbiological study. Okay, this one per Petri plate. So this one refer to volume. Okay, volume or speed or distance, itu semua termasuk dalam volume. Okay, ini adalah contoh-contoh time interval. So kita nak kenal pasti dia adalah Poisson distribution. Dalam soalan dia ada nyatakan average tersebut dalam sesuatu time interval. Maybe day, maybe book, maybe second, maybe volume. Okay, so dia boleh menggunakan time interval tersebut. Okay, so kita lihat seterusnya formula of Poisson distribution. So we have probability x equal to x, where e power of negative lambda, okay, lambda power of x over x factorial. Okay, this one is lambda power of x over x factorial, where x is a discrete number. Okay, 0, 1, 2, 3, and so on. Okay, this one, formula for Poisson distribution. And then we can write Poisson distribution as x, PO. Okay, P, this one for Poisson, okay, in bracket lambda. Okay, lambda is a parameter for Poisson distribution. Okay, mean lambda adalah mean for occurrences in the time interval. Okay, ingat ya, lambda adalah mean number ataupun average ataupun expected number. And then lambda always positive. Okay, lambda always positive. Okay, now we look for example 5. If x distribute Poisson with lambda 6, find the probability by using the Poisson formula. Find x equal to 3. So by using the formula, so remember that the formula is e power of negative lambda, okay, lambda power of x over x factorial. So for this one, e power of negative 6, lambda is 6, okay, 6 power of 3 over 3 factorial. Okay, use your calculator. We have the answer is 0.0892. Okay, next we have x greater than or equal to 2. So we can calculate as 1 minus probability x equal to 0 minus probability x equal to 1. So 1 minus e power of negative 6, 6 power of 0 over 0 factorial minus e power of negative 6, 6 power of 1 over 1 factorial. Okay, and the answer is 0.9826. Okay, x less than 2. So, probability x equal to 0 plus probability x equal to 1. Plug in into the formula. E power of negative 6, 6 power of 0 over 0 factorial plus e power of negative 6, 6 power of 1 over 1 factorial. And the answer is 0.0174. Okay, D. Probability x less than or equal to 5, greater than 2. So let 0, 1, 2, 3, 4, 5. So include 5 without 3. That means we need probability 4 and 5 only. 4 plus probability x equal to 5. Okay, now plug in into formula and calculate. We have the answer is 0.2945. Okay, Poisson distribution. Okay, this one kita mencari Poisson menggunakan formula. Okay. Seterusnya kita boleh menggunakan table untuk mencari Poisson distribution. Okay, kenapa kita perlukan table? Okay, table ni lebih memudahkan pengiraan lah. Okay, kalau kita terpaksa mengira nilai probability yang sangat panjang, so dia sangat sukar dan cerewet lah. Jadi kita boleh gunakan table untuk memudahkan pengiraan. Dan kita kena ingat bahawa Poisson distribution table ni adalah probability greater than or equal to. Ingat ya, dia menggunakan greater than or equal to. And the smallest value lambda for Poisson distribution is 0.1 and the largest lambda is 30. Okay. Now look for example 6. If lambda if the x distribute Poisson with lambda 5.5, okay, lambda is 5.5. So please refer your table, find the lambda 5.5 and find the R equal to 5. Okay, the question is x greater than or equal to 5. So the answer is 0.6425. Okay, refer the table. Okay, next, probability x less than or equal to 5. So if we have 0, 1, 2, 3, 4, 5, 6 and so on. Okay, we need the probability x less than or equal to 5. So from 5 to negative infinity. Okay, less than 5. So we can find the probability by subtract 1 with probability x greater than or equal to 6. Okay. Kita consider all probability adalah 1. Kita tolak kawasan ni. Kawasan ni adalah x greater than or equal to 6. So, please refer your table. Okay, x greater than or equal to 6 is 0.401 minus 0.4711. Okay, so we have 0.5289. Okay, probability x equal to 5. How to find this probability by using table? Okay, look here. If 0, 1, 2, 3, 4, 5, 6, and so on, 7, and so on. So, kita perlu mencari probability x equal to 5. Okay, x equal to 5. So, macam mana kita nak cari? Kita perlu menggunakan kawasan yang lebih besar. Bermaksud, kita kena gunakan kawasan yang lebih besar daripada 5. Probability x greater than or equal to 5. Okay, minus yang ini. Okay, ini adalah probability x greater than or equal to 6. So, kita cari. Okay, lambda is 5.5. R is 5. So, 0.6425 here. Okay, minus x is 6. So, 0.4711. Then, the result is 0.1714. 4. Right? Okay. D, probability x less than 8 but greater than or equal to 3. So 3, 4, 5, 6, 7, 8. Include 3, not include 8. Therefore, this one is probability x greater than or equal to 3 but less than or equal to 7. So how to find this probability? Okay, we use this area from 3 to infinity. This area is probability x greater than or equal to 3, right? Minus this area. Kita perlukan ni ya, 3, 4, 5, 6, 7, 8. 3, 4, 5, 6 dan 7 sahaja. Jadi kita perlu tolak kawasan ni. Kawasan ni adalah x greater than or equal to 8. So, probability x greater than or equal to 3 minus probability x greater than or equal to 8. So, please refer table. Lambda is 5.5. X is 3. So, 0.9116. X is 8. So 0.1905. Then we have the answer is 0.7211. Like this. Alright. So this one by using Poisson distribution table. Next objective is find the mean and variance of Poisson distribution. Okay. If x is a random variable following the Poisson distribution, then the mean of x is lambda and the variance of x also lambda. Ya, expectation mean dia juga adalah lambda, variance juga adalah lambda. Okay, kita tengok contoh. An average of 3 cars arrive at a highway toll gate every minute. If this rate is approximately Poisson distribution, find EX. EX is mean. So from the previous, EX adalah lambda. So apa lambda dalam kes ni adalah dia beri the average of 3 cars is 3. Standard deviation juga adalah square root of variance. So variance juga adalah lambda. So set 3. Okay, next. The third one, use the Poisson distribution to solve related problems. Kita masuk kepada menyelesaikan masalah menggunakan Poisson distribution. Okay, look for example 7. An average of 3 cars arrive at a highway toll gate every minute. Okay, they mention dekat situ average 3 cars in every minute. So this one is time interval. So kita kena tahu average yang dia bagi tu untuk berapa masa. So this one lambda given this lambda 3 per minute. If this rate is approximately Poisson distribution, what is the probability that exactly 5 car will arrive in 1 minute? So, kita tulis dulu X the number of car arrive at a toll gate. So, X distribute Poisson, lambda dia adalah 3. Okay, ingat 3 ni adalah per minit. Per minit, untuk 1 minit. So, soalan pertama, find the probability X exactly 5 car. Right, exactly 5 car. So, kita boleh, ada dua cara. Kalau equal to any number constant, kita ada dua cara. Yang pertama, kita boleh guna formula. So, formula is e power of negative 3 times 3 power of x. X is 5 over 5 factorial. Then, we have 0.1008. Okay. Cara yang kedua, awak boleh gunakan table. Cara yang kedua, kita boleh guna table. So, kalau awak nak guna table, kita mesti gunakan formula greater than or equal to. So, probability X equal to 5 is probability X greater than or equal to 5 minus probability X greater than or equal to 6. Okay? So, boleh dapatkan nilai dia. Dapat. Right. Okay, B, find the probability X exactly 7 car will arrive in 5 minutes. Tadi 3 adalah untuk 1 minit. Sekarang ni dia nak probability 7 car tapi dalam 5 minutes. So, kita kena ubah lambda tersebut kepada 5 minit. So, this one for per 5, untuk 5 minit. So, kita perlu tukar lambda 3 untuk 1 minit. Jadi, untuk 5 minit, kita kena darab 5. Okay, jadi, X is distribute Poisson 15. Mesti kira untuk perubahan minit. Okey, baru boleh kita cari probability X equal to 7 in 5 minutes. So, kita guna formula saja. E power of negative 15. Okay, lambda is 15. Power of 7 over 7 factorial. And then, the answer is 0.01037. Okay, jelas? Okay, kita pergi kepada exercise 11. The number of breakdowns in a particular machine occur at a rate of 2.5 per month. Assuming that the number of breakdowns follows Poisson distribution. Okay, find the probability that more than 3 breakdowns occur in a particular month. B, less than 10 breakdowns occur in 3 months period. Okay, so the lambda 2.5 is per month. Time interval dia adalah month. 1 bulan. Jadi, X kita adalah apa ni? X about the number of breakdown occur. So X distribute Poisson 2.5 for 1 month. The question is, find the probability that more than 3 breakdown. So X greater than 3. So X greater than 3 not include 3. Maksudnya kita kena ambil satu lagi nombor bulat dia ke atas, iaitu X greater than or equal to 4. So kita boleh gunakan table. Kita cari Poisson lambda 2.5. So awak akan dapat 0.4562. Okay, more than 3 breakdowns. B, find the probability that less than 10 breakdown occur in 3 months. Okay, 3 months. This one is 3 months. So probability X less than 10. So less than 10 tapi untuk 3 months. Jadi berubah, time interval dia berubah daripada sebulan tadi. 2.5 adalah untuk sebulan. So sekarang ni dia nak cari untuk 3 bulan. Jadi kita kena ubah dulu X distribute Poisson 2.5 untuk sebulan. Jadi untuk 3 bulan kita darab dengan 3. Jadi X awak adalah, yang terbaru adalah Poisson berapa? 7.5. Lambda awak telah berubah kepada 7.5 untuk 3 bulan. So, probability X less than 10 equal to probability X less than or equal to 9. Okay, less than. That means kalau less than, awak nak guna table. Kalau awak nak guna table, kita kena gunakan satu lagi formula. 1 minus probability X greater than or equal to 10. Okay, so 1 minus 0.2236. So we have 0.7764. Okay, next for same exercise, exercise 11. Find the probability exactly 3 breakdowns occur in 2 months. Okay, probability exactly 3 for 2 months. In 2 months. Okay, jadi kita kena ubah sekali lagi lambda. Lambda asal tadi sebulan adalah 2.5. Sekarang ni adalah untuk 2 bulan. Jadi kita darab dengan 2. So, Poisson awak telah berubah lambda dia kepada 5. Barulah kita boleh cari probability X equal to 3 by using formula e power of negative 5 times 5 power of 3 over 3 factorial. So we have 0.14037. Okay. Or we can use table. So to use table, we can use the formula probability X greater than or equal to 3 minus probability X greater than or equal to minus probability X greater than or equal to 4. So find by using table. This one is using table. 0.875. 3 minus 0.7350. The answer is 0.1403. Okay. Next example is exercise 12. An average number of books sold at a bookshop per week is 10. Average dia adalah 10 dalam masa 1 minggu. So interval time dia adalah per week. Ya, ingat per week. So X sebab apa? X adalah the number of book sold in a week. Then X distribute Poisson. Lambda is 10. Lambda is 10 per week. Remember, this one for per week. The probability is the question is find the probability that 5 books are sold at bookshop per week. Find the probability X equal to 5 in a week. Okay, we can use table. Probability X greater than or equal to 5 minus probability X greater than or equal to 6. Use your table. Find the value for probability X greater than or equal to 5 is 0.9707 minus 0.9329. Then we have 0.0378. B, the probability that less than 4 books are sold. Less than 4 books. Probability X less than 4 books. So, this one is equivalent to probability X less than or equal to 3. Then, 1 minus probability X greater than or equal to 4. Okay, we have 0.9897 equal to 0.0103. So this one is same exercise 12. C, find the probability that more than 7 books are sold in 2 weeks. In 2 weeks. So tadi kita ada Poisson 10 in a week. 10 in a week. So sekarang ni kita nak cari lambda in 2 weeks. So X distribute Poisson 10 awak darab dengan 2. Sebab 10 tadi untuk 1 minggu. So, sekarang kita perlukan 2 minggu. Jadi Poisson lambda tadi kita perlu darab 2. So kita dapat distribution baru Poisson 20. Okay. Soalan dia apa? Find the probability more than 7. More than 7, so more than 7 in 2 weeks. So kita dah kira in 2 weeks. So this one is equivalent to probability X greater than or equal to 8. Refer your table. 0.9 992. Okey, ini soalan yang sama. Okay, kita abaikan. Kemudian kita ada few contoh lagi di belakang. Ada exercise 13, 14 dan 15. So yang ini saya nak tinggalkan pada awak untuk awak buat exercise. Okay, saya akan bagi jawapan akhir. So this one, jawapan A is 0.9817, B is 0.0198, C is 0.1353. Okay, exercise 14. A is 0.1849, B is 0.8576. For this exercise, A is 0.3679, B is 0.8647, and C is 0.3837. Okay, please do it for yourself, okay, to get to practice, ya. Untuk soalan untuk chapter 10 akan ditanya dalam kedua-dua section A dan section B. Okey, itu saja daripada saya.